In 1971, Lockheed was one Senate vote away from collapse. The company that built the SR-71 Blackbird and the U-2 spy plane was weeks from bankruptcy. And the thing that almost killed them wasn't a failed project, it was their biggest win, a military contract they'd beaten Boeing for just 6 years earlier. But that same contract produced an engineering breakthrough so revolutionary that it accidentally made the Boeing 747 possible. To understand how winning a contract became a death sentence for Lockheed and losing it became the foundation of Boeing's commercial empire, you have to go back to 1961. The Cold War was accelerating. America was fielding bigger tanks, wider vehicles, heavier mobile bridges. And the military's existing transports, the Douglas C-133 Cargomaster and the Lockheed C-141 Starlifter, simply couldn't keep up. The C-141 had barely entered service, and already the Army was complaining that its cargo hold was too narrow for roughly half the equipment they needed to move. The United States could build the most powerful weapons on Earth, it just couldn't get them anywhere fast enough to matter. So the Pentagon drew up one of the most extreme aircraft specifications in history. They called it CXHLS, Cargo Experimental Heavy Logistics System. 4 engines, a cargo hold 100 feet long, 17 feet wide, 13.5 feet high. Maximum payload of 180,000 pounds. The ability to land on short, rough runways close to combat zones. And one requirement that had never been attempted at this scale, the plane had to open from both ends. A nose that swung upward and a rear cargo ramp so vehicles could drive straight through without turning around. This wasn't just a bigger airplane, this was a new category of machine. 3 companies made it to the final round: Boeing, Douglas, and Lockheed. All 3 poured months of engineering into their proposals. But from the start, this was really a 2-horse race between Boeing and Lockheed, the 2 companies with the deepest wide-body research pipelines. And the way that race ended is where the entire story turns. The Air Force Source Selection Board spent months reviewing the proposals. And contrary to popular assumption, Lockheed didn't win on connections or corner cutting. Their design was judged technically superior. Where Boeing and Douglas proposed pod cockpits mounted on top of the fuselage, Lockheed ran a structural spine the full length of the aircraft, with the wing spar passing through it. An egg-shaped cross-section ideal for outsized military cargo. They had the better design, the Air Force's confidence from previous transport programs, and the lowest bid. That last detail would become the most expensive mistake in the company's history. It mattered because of a concept called total package procurement, a new model championed by Defense Secretary Robert McNamara. Under TPP, the winning contractor committed to a fixed price for development and production of the entire fleet. Every technical problem, every overrun, every engineering surprise came out of the contractor's pocket. Lockheed signed it believing they could deliver under budget. They were about to find out what that actually meant. In September 1965, Lockheed won the contract. Boeing didn't. At that moment, everyone in the industry thought Boeing had just suffered one of the worst defeats in its history. Lockheed moved fast. They broke ground in Marietta, Georgia, and on March 2, 1968, the first C-5A Galaxy rolled out. This thing was from a different world. The cargo hold stretched 121 feet, 1 foot longer than the entire distance of the Wright brothers' first powered flight. Fully loaded, the aircraft weighed 840,000 pounds at takeoff. 28 wheels across 5 landing gear bogies just to keep it from cracking the runway. The whole aircraft could kneel, lowering its cargo floor to truck bed height, so vehicles could drive straight on. But the most revolutionary part wasn't the airframe, it was the engines. General Electric built the TF-39 specifically for this program, and it represented a genuine leap in propulsion technology. Every jet engine before it had a bypass ratio of 2-to-1 or less. The TF-39 achieved 8-to-1, moving far more air around the core than through it, producing dramatically more thrust while burning about 25% less fuel than any comparable engine. No engine had ever done this at scale. It proved that high bypass turbofan technology actually worked on large aircraft, a breakthrough that would reshape the entire aviation industry in ways Lockheed never intended. Keep that in mind. The C-5 flew for the first time on June 30th, 1968, and on capability alone, it delivered. M60 Patton main battle tanks, Huey and Cobra helicopters, an entire combat-ready military unit loaded from both ends simultaneously, flown to the other side of the planet with aerial refueling. Then the wings started cracking. In July 1969, during static and fatigue testing, the wings failed at 128% of limit load. The requirement was 150%. The wings had been thinned during design to meet Lockheed's weight guarantees, and they physically could not handle the stress the aircraft was built to endure. By the mid-1970s, the Air Force restricted the C-5A fleet to 80% of its design payload. By 1980, peacetime cargo limits had dropped to as low as 50,000 pounds, 1/4 of what this aircraft was supposed to carry. America had built the largest military transport in the Western world, and it couldn't safely lift a full load. And this is where total package procurement became a financial death trap. Every dollar spent diagnosing the wing problem, testing new materials, redesigning structural components, Lockheed paid for all of it. By 1970, the C-5A program had accumulated $1.8 billion in cost overruns, the first military aircraft program in history to breach the billion-dollar mark. Adjusted for today, that's roughly $16 billion of pure, unrecoverable loss. And the C-5 wasn't Lockheed's only problem. Their commercial L-1011 TriStar jetliner was running years behind schedule, sinking hundreds of millions more. By 1971, Lockheed had $1.4 billion in debt, 60,000 jobs at risk, and weeks left before collapse. The Nixon administration made a decision. Lockheed was too important to national defense to let die. In August 1971, Congress passed the Emergency Loan Guarantee Act, authorizing $250 million in federal loan guarantees to keep the company alive. The bill passed the Senate by exactly one vote. 1. That's how close the company that built America's largest military aircraft came to being wiped off the map. The air crews, meanwhile, had their own verdict. They nicknamed the Galaxy Fred. The polite translation is ridiculous economic disaster. In its early service years, the C-5 required as many as 167 maintenance hours for every single hour it spent in the air. Its fuel consumption dwarfed every other transport in the fleet. To this day, it holds the distinction of having the highest operating cost of any weapon system in the entire Air Force inventory. So that's one track of the story. Lockheed won the contract, built the plane, one vote away from dying for it. But the Galaxy story isn't over yet, because years after the bailout, this disaster would find itself in a situation no one designed it for, and earn a kind of respect no spreadsheet could measure. We'll come back to that. Now let's go back to 1965 and follow the other track, the one nobody was watching. When Boeing lost the CX-HLS contract, they were sitting on months of advanced wide-body transport research, structural analysis for a massive fuselage, aerodynamic data for high-mounted swept wings, a cockpit design raised above the main deck to accommodate a hinged, upward-swinging nose, 4 engine pylons, quadruple redundant hydraulic systems, all of it developed to military transport specifications, all of it now with nowhere to go. Except Boeing's leadership saw something almost no one else did. The military didn't want their plane, but the airlines were about to need something exactly like it. Pan American World Airways, at the time the most influential international carrier in the world, had been pressuring Boeing for an aircraft at least 2.5 times larger than the 707. Juan Trippe, Pan Am's chairman, believed transoceanic air travel was on the verge of exploding, and the existing narrow-body jets wouldn't be able to scale fast enough to meet demand. Trippe needed a wide-body, and Boeing, sitting on a pile of rejected military wide-body research, realized they already had a head start nobody could match. Under the leadership of Chief Engineer Joe Sutter, Boeing started designing what would become the 747. Sutter would later clarify that the 747 was an entirely original design, Not a direct copy of their CX-HLS bid, but the DNA was unmistakable. The raised cockpit that had been designed to sit above a military cargo nose became the 747's iconic upper deck hump. The wide-body cross-section, engineered to swallow tanks, became a fuselage that could seat up to 480 passengers in a 10-abreast configuration. The 4 independent hydraulic systems, the military-grade redundancy philosophy, the convertible freighter capability, all of it carried over. But there was one more connection. And this is the one that ties the whole story together. The C-5 Galaxy program had funded the development of the first successful high-bypass turbofan engine. Before the TF-39, nobody had proven that an engine with an 8-to-1 bypass ratio could reliably power a massive aircraft. The C-5 program took that risk. Lockheed and the Air Force paid for it, and once General Electric proved the concept worked, it changed the calculus for every engine manufacturer in the world. Pratt & Whitney, Boeing's engine partner for the 747, saw that high bypass technology was now proven and viable. They developed their own version, the JT9D, specifically to power the 747. Without the C-5 program absorbing the multi-year developmental risk of proving high bypass turbofan technology worked, the JT9D and the 747 it powered might never have been built, or would have arrived years later into a very different commercial market. The Boeing 747 flew for the first time on February 9, 1969, less than 8 months after the C-5's first flight. Look at both aircraft side by side, and the family resemblance is unmistakable. But the 747 wasn't a copy of the C-5. It was what happened when a defeated team took their own military research, combined it with a commercial engine made possible by their competitor's program, and bet everything on a market that didn't yet exist. Over the next 54 years, Boeing built 1,574 747s. The aircraft democratized long-haul air travel, carried space shuttles on its back, served as Air Force One, and generated revenue that made Boeing the dominant force in commercial aerospace for decades. Lockheed built 131 C-5s. They survived the bailout, but barely. They exited the commercial aircraft market entirely after the L-1011 TriStar failed commercially, and wouldn't fully stabilize until merging with Martin Marietta in 1995 to form Lockheed Martin. That's the business side of the story. The contract that broke Lockheed, the defeat that built Boeing's empire, the engine that rewrote aviation. If the C-5 Galaxy was just a cautionary tale about procurement and irony, this is where the video would end. But it isn't. Because everything you've just heard, the wing cracks, the billion-dollar overruns, the Fred nickname, the Senate vote, none of it explains why this aircraft is still flying 60 years later. None of it explains why the Air Force has no plans to replace it. And none of it explains what happened on April 4th, 1975, when a C-5 Galaxy did something no spreadsheet could ever capture, and earned a kind of respect no balance sheet could ever measure. With North Vietnamese forces closing on Saigon, President Gerald Ford ordered the evacuation of orphaned children from South Vietnam. They called it Operation Baby Lift. The first flight was a C-5A Galaxy, loaded with 314 people. Most of them were infants and young children. Many of them had been secured in cardboard boxes and makeshift restraints in the cargo hold, because the plane had never been designed to carry human beings this way. 12 minutes after takeoff from Tan Son Nhut Air Base, climbing through 23,000 feet over the South China Sea, the locks on the rear cargo loading ramp failed. The door blew open with explosive force. The decompression ripped through the fuselage, severing control cables to the tail. 2 of 4 hydraulic systems failed instantly. Captain Dennis Traynor lost the rudder, lost the elevator. What he had left was one working aileron, the wing spoilers, and engine power. That was it. And here's the detail that makes the story worse. The cargo door locks that failed had been cannibalized from other aircraft and improperly installed during maintenance. The failure went unnoticed during inspection because there was organizational pressure to get the flight airborne. Traynor and his co-pilot, Captain Tilford Harp, had to steer the crippled aircraft through asymmetric throttle, pushing more power to engines on one side than the other. They turned the Galaxy back toward land. In the cabin, First Lieutenant Regina Auna and her medical team moved through near darkness, checking restraints on hundreds of children. They repadded them, retied seatbelts, prepared for a crash they knew was coming. Two combat photographers switched on their high-intensity lights so the nurses could see. Trainer brought the C-5 down in a rice paddy 2 miles short of the runway. It hit at 270 knots, skidded for a quarter mile, became airborne again for another half mile, crossed the Saigon River, and broke into 4 sections. The cargo compartment where most of the children were held was completely disintegrated. 138 people died. Captain Mary Clinker, a flight nurse, became the last American servicewoman killed in Vietnam, but 176 people survived. Lieutenant Auna, despite a broken foot, a broken leg, and a broken vertebra in her back, carried approximately 80 children out of the wreckage to medevac helicopters one by one until she physically collapsed from her injuries. She became the first woman to receive the Cheney Award. The flight crew received the Air Force Cross, and Operation Baby Lift continued, evacuating more than 3,300 children from Saigon before the city fell. That's what the plane they called a ridiculous economic disaster did when it mattered. Today, all 52 remaining C-5s have been upgraded to C-5M Super Galaxies. New engines, modernized avionics, a projected service life past 2040. And here's where the story closes its loop. The engines now powering the C-5M are General Electric F-138s, a military version of the commercial CF-6, which itself was a direct descendant of the TF-39 that started the entire program. The engine family that nearly bankrupted Lockheed in the 1960s came back 60 years later to repower the very aircraft it was built for. And those same engines, in their commercial form, have powered generations of wide-body jets. The Boeing 767, the Airbus A300, A310, A330, and the McDonnell Douglas DC-10 and MD-11. Thousands of aircraft across the global fleet, all tracing their lineage back to the engine that was built to lift a single military cargo plane. There is no replacement planned for the C-5. 60 years after it first flew, it remains the only aircraft in the Western world that can carry what it carries to the places it goes. Lockheed nearly bled out building this aircraft. Boeing built an empire from losing the contract for it. And a broken Galaxy with one working aileron brought 176 people home from the last days of a war. The C-5 was never supposed to be any of these stories. It was supposed to be a cargo plane. But the best machines, like the best decisions, rarely end up meaning what you thought they would when you built them. And the engine that started all of it, the high-bypass turbofan the C-5 program proved could work, became the blueprint for every large commercial jet engine that followed. Every time you board a long-haul flight today, you're riding on an engineering gamble that nearly destroyed one company, accidentally built the commercial empire of its competitor, and changed the shape of the sky forever. All because of a military cargo plane most people have never heard of.